Can you hear us?
Yes, hi, hello.
Woohoo! Um, so we're still missing a few students, but we'll go ahead and start. I don't want to take too much of your time. Um, what would you like us to call us, or what would you like us to call you?
That's a good question. Dr. Rigby is fine.
Dr. Rigby? Okay, cool. Just come grab a seat over here. All right. So, Dr. Rigby, would you go ahead and introduce yourself, because you know more about you than I do, and that would be the best person to do it, I think.
Okay, sure. I am Jane Rigby. I am an astrophysicist at the NASA Goddard Space Flight Center. NASA has a dozen centers spread over the U.S., and we are at Goddard, which is in Maryland. So, yeah, so I'm an astronomer. I study galaxies. I study black holes in the centers of galaxies. And one of the big things that we do here at Goddard, well, two big things. We run the Hubble Space Telescope. So has everyone heard of Hubble? Right? Has anyone not heard of the Hubble Space Telescope? Okay.
We have to say no.
Yeah. So we run Hubble, and I use Hubble a fair bit. And then we're building a telescope that will come after Hubble, because Hubble's already 24 years old, which is really old for a telescope. So at some point it will die, and so we have to build the telescope that will come after it now. These things take decades these projects take decades. So I am one of many scientists and engineers working on building the next telescope after Hubble, which is called the James Webb Space Telescope. Webb with two B's. So the Webb telescope I can talk about, but so I spend kind of half my time working on the Webb telescope and making sure that when we build it, it'll do the science. That's the whole reason we're building it. And then I do my own science, study galaxies, study black holes.
Cool, thank you. Thank you very much.
And you froze.
Twitter, man. Twitter.
When did y'all do that?
See, I think she agreed to do it 2 days ago. Is that right, Dr. Rigby? Can you hear me?
Yeah.
Yeah, was it 2 days ago that you said you'd help us out?
Yes. Uh-huh.
Yeah.
I wasn't here.
Yeah. No, I
Sure.
did.
Yes.
On the weekend.
Oh.
Why don't you, now, if I'm not mistaken, the Hubble telescope was scheduled to be, I guess, decommissioned a few years ago. Is that correct?
Yes. After the Columbia space shuttle disintegrated with the loss of the crew, there was a complex series of decisions. First, not to service Hubble again, and then eventually to service Hubble one final time. So Hubble got a second chance at life, and that was now 5 years ago. So we've had the refurbished, better than ever Hubble with its new instruments for 5 years now.
That's awesome.
So when are y'all going to get rid of it?
I was waiting for that. I'm like, all right, he's going to ask, so when it dies. The short answer is we don't really know. So Hubble, as a telescope now, is so far out of warranty, right? We don't know how long it'll keep working. We all want it to work a really long time. And so, every year I use Hubble. It's such a fantastically productive telescope. And so right now it's working great. Everything's working fantastically. I think they've had problems with one gyro, but the gyroscopes that allow it to point accurately. But it has backup gyros, so that's fine. So hopefully we'll get to use it as long as it's scientifically productive. So there's two questions that determine how long Hubble lives and then when it dies. The first is when pieces start breaking, like important pieces, like it's like not all the instruments are working. That hasn't happened yet, but eventually stuff gets old, it'll start failing. And the other is the tube of money. The Hubble is run by the United States, most is the NASA, and then contributions from Europe, but most of it's from the federal taxpayers. And so, the money needs to keep coming from the public through NASA, and it needs to be scientifically productive. So at some point, if it stops working well, we'll have to have this really hard conversation about when to pull the plug and when to let it die. But so far, everything's working great.
Cool. Thank you. Any other questions about Hubble before we get to the questions you guys wrote?
What is that, whatever?
What?
What is that, whatever it's called? The gyro, whatever?
Gyro. You ever seen a gyroscope where you pull the string and it spins? It's not the top. It's got this little.
I don't know what you're talking about.
Sometimes if you say gyroscope, it helps people. I'll have to show you a picture of one. It's a spinning tool, and I don't know. Is it It's not a mechanical one on the.
The old ones used to be. The new ones use lasers, and I don't really know how they work. But it's a thing that tells you how you're turning and how you're pointed. When you're in space, you have to be able to point. We have to be able to point Hubble very precisely, and so there are a bunch of onboard systems called gyroscopes. But they're based on the same principle as the gyroscope that I'm sure you'll get tomorrow in class, but more complicated. But it's just the principle of knowing where you're pointed, so you can point where you want to be.
Cool. Yeah, I'll see if I can find my old one and show them either that or I'll just show them a picture. But okay, so students wrote several questions. You guys remember what because I don't know if I have your list printed out, but maybe we'll just go from one of these. Ricky, would you be willing to read one for us?
I will. Yeah, I'll read like 12 of them.
Here you go.
Yes. Is there anything on Earth that can compare to the sun in temperature?
Oh, that's a good question. There's lots of things that are hotter. So the outer parts of the sun aren't that hot. They're like 5,000 Kelvin. So really not that hot. So let's see. You can. So yeah, we can make stuff that's hotter than that pretty easily. The center of the sun, right, where the nuclear fusion is happening, is a lot hotter. So that's millions of degrees, and that's, I don't know that there's anything on Earth that's nearly that hot. I don't think so. So yeah, surface, yes, interior, no.
So you said the center is millions of degrees, is that right?
Oh yes, but now you're going to make me go look at my physics textbook and look it up, because it's one of those numbers I haven't used in 15 years.
No, yesterday we were talking, I think we saw it was like 18 million degrees before fusion starts.
Depends on the pressure, but yeah.
Okay. Cool. Let's see.
Dude, I want to read one.
We'll give you a chance. You've already asked a question.
No, I haven't.
I haven't.
I'll ask the question.
So here's one for you. How long?
How long will there still be life on Earth when the sun ends?
The last part of that?
Sun ends.
The sun ends? So that we have about 4 or 5 billion years before the sun starts its death throes. So we have, 5 billion years. We have some time. I would expect that. So when the sun ends its life, it becomes a red giant. It swells up. And at that point, life on Earth becomes pretty much impossible. The Earth may survive or it may not, but certainly it is not a place that you would want to be living. But the sun has about 10 billion years of life for the size of the sun, and it's about halfway through that life, right? So the sun's 5 billion years old. It'll last until 10 billion, so you've got 5 billion years until you need to leave.
Why do you say life would be impossible on Earth if when the sun goes red giant?
So when the sun runs out of hydrogen in the core, so let's see. So when the sun finishes runs out of hydrogen, right? It starts burning its helium, but that doesn't last very long, and so it ends up the outer layers swell up as the interior gets hotter and hotter, because it's basically during the last parts of the sun's lifetime, it's kind of like, using one credit card to pay off another credit card. Like it's burning things like helium, which don't actually give you a lot of energy out. So they're sort of short-term fixes. So the sun spends most of its life burning hydrogen. Then when it runs out of that, it burns a little helium, and then it's that doesn't work very well, and it runs out of fuel. So when it does that, it's really hot in the center, and so the exterior puffs up. And that puffing up can be like the size of the current solar system. So if you think about the sun as a nice, well-behaved little star, when it is close to the end of its life, those outer layers are swollen out to something like the orbit of the Earth. So this is when it's a red giant. So it'll be a lot hotter, so that's going to burn off the water. And it may even swallow the Earth. It kind of depends. But in either case, it becomes a really ugly place to live.
How? What?
Because she said
It's going to be too hot or too cold?
Way too hot.
The sun's going to expand and possibly engulf the Earth, so we'll burn up.
We won't because we'll be gone.
Yeah, I'll be
You
dead.
think so, huh? Maybe you're talking about humankind, maybe?
I guarantee you humankind when you before this. I know.
Okay, we got another
What is
question.
a red giant?
A red giant's a really big star at the end of its life.
So how long will it last? Is that?
How long will it last as a red giant?
It's really short. I don't remember. It's like millions of years, not very long.
Oops.
Compared to 10 billion years.
Not very.
Yeah.
Yeah, it's not very long.
That's a long time.
Compared to 10 billion, it's not. Go ahead.
Why does it take 18 million degrees to create a star?
I don't know.
Good answer. Good answer.
I don't think I understand the question. Sorry.
I guess we could kind of revise the question. Why does it take so much energy to start fusion in a star?
Okay. This partly, it's just hard to get fusion to work, right? You need really, really high temperatures and high densities because you're trying to make atoms that, want to be their own thing, and get them close enough together that hydrogen turns into helium. That's just energetically really hard to do. So you need really extreme densities or really extreme pressures. Really extreme pressure. You need really extreme temperature, and both preferably. This is part of why no one's been able to do fusion on Earth, right? If we could do fusion on Earth, like in Back to the Future, that would solve our energy problems. But it's really hard to do. People have been able to do it in rather huge laboratories but just a little bit, and not enough that you could, power houses out of it.
All right. Any lead-off questions from that?
Yeah.
Okay. Let's see. Looks like I printed a couple long lists. Well, I printed the same list twice, so that's going to be a problem. You guys turned in your other questions, right?
Yeah.
Okay. Anyway,
You just immediately worked the ISS, so how can I tell you anything?
I wasn't. That's why I'm looking at you, because obviously not. Yes, we have a question from Tucker. Be prepared.
Can you turn the camera to Tucker so she can see who Tucker is?
Hey, go ahead. Oh, the other ones are from another class, actually. So I've got a question about elliptical galaxies.
Okay.
So they don't have a lot of new star formation, correct?
Correct.
Okay, so why is that?
So there's different types of galaxies, and most, not all, but most galaxies that we call ellipticals, because they look big and round and don't have big spirals in them, most of them are dead. They're just not forming new stars. And that's actually not a solved question. That's a big open question, because we know that now there's not a lot of new stars forming in the universe. And a few billion years ago, there were a lot more. It was like 10 times more star formation. So that's an ongoing topic that people try to figure out. What stopped star formation in the universe? And why do elliptical galaxies just turn off? They get completely clear of their gas, and they don't form any new stars. So the answer is nobody knows, but that's something that we work really hard to try to understand.
Gotcha.
Is there life in other galaxies?
We don't know.
How do we not know?
How would we know?
We haven't been on all of them.
We haven't been to any of them.
Travel.
What do you think? What do you
Travel.
think?
Send a satellite.
No, stop. What do you think?
Well,
Yeah. What do you think? Do you think there's life in other galaxies or not?
Well, I don't know. Should you listen to what I think if I don't have any good evidence to back it up?
You really should. I think there is.
Right? Well, why?
Just because there's no way we're the only people ever. No possible way.
So what you've just said is called the Copernican principle, and it states that we're not special, right? And so, we're not special. Okay, we're all special snowflakes, right? But that we're not the only, ours is not the only planet that could form life, and ours is not the only, intelligent life forms. So it's a gut feeling, right, what you're expressing, and it's one called, that has a name. And it's a really common gut feeling, because why would we be the only ones? But we don't have any evidence. A lot of people here at NASA are working hard to build telescopes that maybe, by the time before we die, like within our lifetimes, we could test for signs of life on other nearby planets around other stars. But it's going to take like 40, 50 years to build the telescopes that are capable of doing that. Like, it's not easy.
So, do y'all know for a fact that we're the only planet in our galaxy that has a life form on it?
No, for a fact. No, we're just the only one we found.
Do what?
Well, Earth is the only planet we know of that has life, but it's really hard to test, right? It's really hard to make the measurements. So we haven't been able to make the measurements about whether there's life on other planets.
So
It's been hard enough just to find the other planets.
No, how many planets have water on them?
We don't know that either.
Frozen.
What's that?
Yeah, we don't know that either. Finding water is something we've just started being able to do on Jupiter's around other stars.
Cool.
So Jupiter.
What's we got a hand all the way in the back.
Yes.
Others. This isn't just a question relating to stars, but what happens if two equal-sized stars did collide?
Oh, what happens if two equal-sized stars collide? Well, that hardly ever happens because there's a lot of space between stars. But it does happen down in the cores of globular clusters in places where there's tens of thousands of stars all spinning, all orbiting each other. And so when that happens, it depends how big the stars are. If they're just ordinary stars, then they are weird. They have weird lifetimes. But, it happens. And so, let's see. So what would happen? I've never thought about that before, so I have to work it out. So after all the dust settles, you would get one bigger star, right? But it seems like that would be a very violent process. I don't know what to think about that.
Hold on. Let's give someone else a chance.
I have a lot of questions.
I know, but other people want to ask too.
It's not fair.
Haley?
Is the first star that was ever created still floating?
Oh, okay. Are the first stars still around? That's a really good question. So my friend Anna, who's up at MIT, has worked on this for a long time. So if the first stars that ever formed, the big ones, like the massive ones, would have blown up a long time ago, because big stars only last a couple million years. But the little ones that are smaller than the sun should have lasted a long time. So for a couple decades, people have been going to try to find them. There are one or two stars that have been found that look like they could have been some of the earlier, very early stars, right? They're like 13 billion years old, and the universe is like 13.7 billion years old, and they have almost no heavy elements. They're just hydrogen and helium, basically. So that implies that they formed at a time when the universe hadn't made many of those elements. So we found maybe like between 0 and 3 of these things. There's just very, very few, and they're very rare. And then people argue the way scientists argue about whether they're really the first or whether they're the second, third, the second generation. But they've been really hard to find, and this is kind of puzzling. There should be more of them. And so there are either some very weird things happened when the first stars were forming, such that they never formed stars that stuck around. That would be really weird. or we haven't found them yet. So there's some new surveys coming online that should find them in the next couple years, if they're out there. And if not, then we have to totally rewrite how we think the first generation of stars formed.
How do you even know the age of stars?
That's a good question too. Oh boy. That's a really good question, and I'd have to go check. I don't remember, and I don't want to just make something up.
You said that the biggest stars only last a couple of million years, but the sun lasts like 10 billion. How is the sun supposed to be the biggest star?
No, sun's dinky. Sun's dinky. There's tons of stars that are, 25, 30 times as massive as the sun.
What?
Yeah.
Where?
The sun is just close to it.
Oh, never mind. Never mind.
Yeah, they're all.
So is the sun the closest star to us?
Come on, Blake.
I know, like, because I mean, there's others. I see other stars at nighttime
Do you
too.
see they show up as big as the sun?
No.
Then they're not as close.
Are all stars?
But how is the sun the center of our universe?
No.
Okay, but the sun is a star and it's just close to us.
Does
So if we
each
got really
star
close
have
to a
their
star,
own-
would it be like the sun? Like
Yes.
Like, why is it
Yeah.
so? But why is the sun got so much gravitational pull to be the center of our universe?
Because we're center of our galaxy,
Yeah.
our solar system.
Yeah, our solar system. Like, why? Why? Just the sun. There's other stars out there. Why?
Because we formed around the sun.
Exactly. How?
We've been
There's
talking
other
about
stars
it.
out there that I see every night.
Yeah, there's other stars.
All right, hold on. Hold on. Dr. Rigby, I know we've already gone over our time with you. Can you handle one more question?
Let's do one more, yeah.
Okay. Did you have another one?
I was just gonna ask,
Oh, listen, wait,
does each star have like their own thing, like our galaxy does, like
Their
with
own
different
solar
planets
system?
and their own?
So that's a question that we did not know for a long time. And the Kepler spacecraft, which NASA launched a couple years ago, and just stared at the same part of the sky for years, Cygnus in the Milky Way. So the Kepler spacecraft has found a couple thousand planets orbiting other stars. And one of their biggest results is that on average, and so Kepler was really neat because Kepler could find planets that are the size of ours, right? Find Earth-sized planets, as well as a whole lot of bigger planets. And the big result from Kepler, there's a couple, but one of the biggest, is that on average, right? On average, about every star has a planet that's Earth-sized. Right? Now that's on average. Some will have several, some will have none, and that doesn't mean that those planets are in Earth-like orbits, right? Kepler was more sensitive to, it was easier for Kepler to detect planets much, much closer to their star. But still, the result from Kepler, which we didn't know, and now it's just like, holy crap, we really know that, is that roughly every star you see, every star has a planet, roughly. That's the mass of the Earth, which is just cool, right? So that means that there's, of known planets, thousands of known planets now, and you can extrapolate to the fact that there's hundreds of millions of stars in our galaxy. There must be something like hundreds of millions of planets.
Awesome. Thank you so much, Dr. Rigby. I really appreciate your time and your effort and being willing to do this with us.
All right.
I'll send you the link to the broadcast later today.
Okay. Take care, y'all.
Awesome.
See ya.
Thank you.
Bye.
You didn't even ask my favorite question.